Hello dear students. Now we are going to start a next topic of 10th class, that is center of gravity. This topic is so far related with the previous topic, that is moment. As we have studied in the last topic, that is moment, the product of force and perpendicular displacement. Okay. Now come to the point. Center of gravity. What is center of gravity? For a simple language, if we say that if any object simply balanced at a certain point, that certain point will be called as center of gravity. This is normal definition. With mathematical terms, we can simply simplify it. As we know that the masses is of any object having mass, it means that it has contained many particles. And each particle has some mass that will combinedly affect as weight, that will be always towards the center of the earth. As we have mentioned here in this diagram, this irregular shaped body has many particles. It consists of many particles. Let's say that M1, M2, M3, so on. There are many particles, and each particle is exerting a force, that is weight, directed towards the center of earth, and that's why it's always towards the earth, means that vertically downward towards the center of earth. As we have studied in class 9th, that a force of gravity is always towards the center of earth. That's why each and every particles of this body will experience a force, means weight, towards the center of earth, and that will be parallel to each other. ये सब के सब अपने आप में क्या होंगे? पैरेलल होंगे. The certain point, at one point in the whole body, a certain point will come where the whole effect will be considered at that point. That point is called as center of gravity. For example, center of gravity of a body is the point about which the algebraic sum of moments of weights of all the particles consisting the body is 0. Means that whole of moment produced by the weight of each and every particles will be 0 at that certain point. That certain point is called as what? Center of gravity of that body. The entire weight of the body can be considered to be at this point. Means on that certain point, entire weight, the weight of the body will be considered. Okay, as shown in this figure, there are many points: W1, W2, W3, W4, W5, W6. Each where have some weight directed towards earth, while at a certain point G, where the whole weight is considered to be concised. Okay, means that when a body has combinedly effect, its moment at a certain point is 0, that point is called as what? Center of gravity of that body. For example, let's say this is marker and it has a center somewhere inside this line. Okay, and at that center it will be balanced itself. If I put here, it will be balanced itself. That point will be called as center of gravity. For example, any object, if you want to take, कोई भी आप ऑब्जेक्ट लेंगे और उसके सेंटर्स को होल्ड करेंगे. फॉर एग्जाम्पल, लेट देयर इज a square book. Here I am balancing putting at a certain point, balancing this object, means that point will be called as center of gravity of that object. Okay, where the whole mass is balanced. Okay, Come to the some point related about center of gravity. Okay. First point, center of gravity of a body depends on its shape. Simply, uh, the center of gravity will depends on the shape of the body, how the shape is. If it is different shape, its the center of gravity will, the position of center of gravity will change. Similarly, for example, here is a wire, long wire, a straight wire. Its center of gravity will be mid of this wire, means that whatever be the length of this wire, you have to put it simply half, and that point there will be the center of gravity. By this wire, if I am making a circle by using the same wires of same length, if I am making a circle, okay, a ring, by this wire I have made a ring. Now the center of gravity of this ring will be the center of the circle, okay, not the midpoint of the wire, okay. As this is the same wire from which I have made a circle, it has same mass, same length, though the center of gravity has changed. That's why we conclude that center of gravity of a body depends on its shape. Means that center of gravity definitely depends on the shape of a body, shape of the object. Okay. Now, next point is, it is not necessary that the center of gravity always be within the material of the body. Means that if I am saying that my center of gravity will be always within the body, it is not necessary. For example, if you take a ring, the material is present at the circumference of the ring, not at the center. Okay, the material of the ring is present at the circumference of the ring, not at the center. So the center of gravity might be outside the body. Okay, it will be outside the body, means there is no material needed for the center of the body, requirement for the center one. For example, same example, if you take a hollow sphere, the materials of a hollow sphere is outer parts, not at the center. That's why it is outside. Okay, that's we can say that the center of this types of body, the center of gravity of this types of body may lies at the center, at the inside the body or outside the body. Okay, it is not fixed that always it will be right outside, but outside the body always it will be lies inside the body. It may be outside the body, it may be inside the body. Okay, if you take a solid sphere, there will be the center of gravity will be always within the body, within the material of the body. Okay, the next point is, by this concept of center of gravity, a body of weight W can be considered as point particles of weight W at its center of gravity. Okay, for example, if there is a body, some body, the solid body it is, okay, and it has a weight W, okay. By replacing this body, we simply put a point, that point, and we considered a W. Okay, we considered at W. By replacing the body, we considered a single point of that body, and that will experience a weight of W. We can replace it, we can take it a point object. Okay, next on next point, come to some shapes having center of gravity. Okay, come to the point of some shapes of having center of gravity. Okay, for example, if we are taking rectangle. Where will be its center of gravity? Rectangle. We will draw the diagonal and it will cut at some point. There will be the center of gravity. Means that where the diagonals of a rectangle intersect each other, that point will be the center of gravity of a rectangle. Second, for a triangle, let's consider it for a triangle. Draw the median of a triangle. If I am drawing the median of a triangle, let's say A, B, C, a triangle. Okay, and if we are drawing median BD or AC, AP, let's say the point where the two and more medians of the triangle will intersect, that point will be called as the center of gravity of the triangular lamina, means a seat of triangular pieces. Okay. Third, for example, if we are taking a sphere, solid sphere, where will be the center of solid sphere? As we already know that a sphere has a center, that will be its center of gravity. Okay, a solid sphere has its center where there will be its center of gravity. Now come to the point, a square. Again, for a square you have to draw the diagonal and the intersection point of the diagonals will give you the center of gravity of a square. Okay, now come to the point, for a cylinder, either it will be solid or either it will be a hollow. For a hollow or solid cylinder, the center of gravity will be along the axis, midpoint of axis. Okay, midpoint of axis will be the center of gravity. For example, if it is of 50 centimeter, let's take an example. If the cylinder is of 50 centimeter, where will be its center of gravity? Means half of the length. Do half, there will be the center of gravity. 50 divided by 2, that will be like 25 centimeter. From the end, 25 centimeter from the end, you may find the center of gravity of a hollow cylinder or solid cylinder. Both of you may take it. Okay, same as it for a rod if we will take a rod is an example of solid cylinder, so it will be same like that. Okay, now come to the point, how to find the center of gravity of irregular shape. Okay, let's simple, it is so simple to find the center of gravity of irregular shape. Come to the point, let's assume that there is an irregular shape. This is an irregular shape, whatever be the shape we can do. Now I have to find the center of gravity of this irregular sheet of paper. Okay, now simply punch 3 holes. I punches the hole A, hole B and hole C. Okay, simply mark a point anywhere you have to mark it. Mark the point A, B and C. Now, by using a keel or anything, you have to hang through this point A. You have to hang this simply and let them free to what be stationary. After hanging, take a straight wire or a thread you make. By putting this thread here, you have to draw a simple perpendicular. Okay. Again, by another point, you have to hang it and be free to the, and from that point you have to draw the next and draw the next line. At a certain point, these perpendicular lines meet. That will be called as the center of gravity of this sheet. That point will be called center of gravity of this sheet. For example, this is the irregular set piece of paper I have. Now it is irregular set piece. Okay, I have to find the center of gravity of this piece of paper. So for example, I will took 3 points. That will be what? Point A, point B and point C. Okay, simply holding a pin through point A, let it be. It will adjust itself. Okay, now we have to draw a straight line through the point A. Again, take the point B. You have to hang it through a hill. Okay, again you have to draw a perpendicular. Now we will take the point C. It will hold up it and draw a perpendicular line. These all 3 lines will cut at a certain point. That certain point will give you the center of gravity of this irregular shape. I hope you are able to understand this. Okay, thank you. This is the normal topic you have today. We have finished it. Okay, thank you. Bye.